Hi guys, welcome back to the channel. So today we are going to be discussing about today's lead code question, which is count subarrays where the maximum element appears at least k times. So we are given an array of nums and then positive integer k. We need to find the number of subarrays where the maximum element of nums appears at least k times in that particular subarray. Suppose subarray means suppose if I take 3, 2 and then 3, this is a subarray. And then let us say if I take 3 and then 3, then this is not a subarray as because it is it is not continuous from starting to ending. So that is the difference between a subarray and then subsequence. Suppose if I take this particular example where I have nums equal to this array and then k equal to 2. Now I need to find all the subarrays whose maximum element frequency is at least 2. So for this particular array, I'm going to consider this particular strategy. So if I come to the brute force solution, if I pick if I pick the starting point and then ending point, and then I'll calculate the frequency of the maximum element in this particular subarray, and then if it is at least k, then I'm going to increment the answer and then I'm going to return the answer. For that, I'm going to use one for loop for starting and then one more for loop for ending, and then to calculate the frequency from I to j, there will be one more for loop. So this will be of big O of n cube time complexity to solve this particular subarray, uh, to solve this particular solution. So we'll come up with one more solution where we have the sliding window. So suppose if I take this particular example, now I'm going to consider left and then right pointer and then k equal to 2. So the strategy is, so instead of calculating at least k, we'll try to calculate all the subarrays which have frequency less than k. So we are going to have the element all the subarrays which have the frequency less than k for the maximum element, and then out of these subarrays, which is going to be our answer, then we are going to return all the subarrays minus this particular answer. That is going to give us the answer of at least k. So this is going to be less than k, and then this is going to be answer, and then we are going to remove the answer from this particular all the number of subarrays we can build from this particular array. So let us see the approach for this. Suppose if I say the k equal to 2. Now the frequency of the maximum element, which is 3, is 0. Now I'll try to move the right to here. Then the maximum frequency is going to be 1, and then again I'll move here. It is going to be 1. Now it is going to be 2. So at this particular case, I'm going to move the left pointer to here. Again, it is 2. Then I'm going to move here. Now the frequency is less than 2. So that's why we are going to move again here. And then now it is 2. So we are going to move left to here and then again to here. And then we are going to calculate all the subarrays whenever it is less than k. So let us go through the code once. So now we have I and then j. J means the right and then I means left. Now I am going to pick the answer equal to 0 and then maximum element as nums of 0. And then out of all the elements we are going to calculate the maximum element which is present in this particular array. And then after that we are going to consider the frequency of the maximum element to be 0, and then each time we visit nums of j, if it is equal to maximum, then we can say that the frequency of the maximum element in this particular window is going to be increased. And then whenever we say the frequency is greater than or equal to k, then we need to reduce this particular, let us think this is the sliding window. Now I have the frequency greater than or equal to k. That means we are going to reduce this particular starting point, so that we'll reduce the frequency and we'll get back to the frequency where the frequency is less than k. So that is what we are doing here. So whenever it is greater than or equal to k, then we are going to reduce this particular left pointer, and then we are going to reduce the frequency. And then at some particular point, if the frequency is less than k, that means if I say I have elements of 1 and then 2 and then 3. Now I is here and then j is here, and then the frequency is less than k. That means I can consider all this array 1, 2, 3, or I can consider 2, 3, or I can consider only 3. So these are the three possibilities which I can have. So that is going to be j minus I plus 1. So that's why we are going to add j minus I plus 1, and then we are going to increment the j. At last we are going to take this particular all number of total number of subarrays, and then we are going to remove this particular answer. Why? Because we are considering the frequency where it is less than k. So that's why we are removing out of those. So let me show one example. So let us think that this is whole thing, and then now we have this is k equal to some 3, and then this is k greater than 3, and then this is k less than 3, k less than 3. Now we need to find this particular thing. Out of all the elements, we need to find this particular thing. Now what we are doing is, instead of calculating this particular case, we are taking all, and then after taking whole, we are trying to remove this particular thing, so that we'll get only this. So that's what we are doing. That's why we are taking all the number of subarrays, and then we are reducing to nums, we are reducing via answer. And then for this, the time complexity is going to be big of n, and then space complexity is going to be big of 1. Why? Because we are not taking any new extra space. Yeah, that's all for this video.